Question number 4, another explosion, literal in this case. We have a rocket that falls apart into 2 equal parts. So if the original mass was m, then that is m/2, and that is also m/2. Originally, the rocket is going 45 meters per second at that direction, which I can call x. I'm free to choose my direction any way I want. And since the angles 30 and 60 are measured relative to that axis, might as well call it x. In an explosion, just as in any collision, momentum will be conserved. Kinetic energy won't. There will be some extra kinetic energy in the case of explosion because explosion happens at the expense of potential chemical in this case. We are going to employ our conservation of momentum. Py equals constant and px also equals constant. They do not change in the x direction and in the y direction. In the y direction, my p initial was 0, therefore my p final is also going to be 0. Now y direction is going to be at 90 degrees right here. You see how they marked v1 and they didn't say v final 1? Because there was no v1 initial to begin with. So I'm just going to keep to v1 and v2, and we will by default know that we're talking about the final, right? m/2 v1, and since I'm talking about the y direction, so I'm going to say y right here to remind ourselves. This will be the vertical part, so this will be through sine of 30 degrees. So basically half of v1. For the second one, it's going to be plus. And for my second object, we have again m/2 v2, and this is sine of 60 degrees. See how it's downward in the y direction? So instead of saying plus, I'm going to say minus, just to remind myself that they are in the opposite direction. Now off to px. P final x is going to be equal to 45, because I know that originally I had 45 times the full m, because it was all one piece and the whole piece was moving at 45 meters per second. Then p final x, in terms of separately moving pieces, it's going to be m/2, because it's half of m like we said, and it's going to be in the x direction. So therefore it's going to be v1 cosine of 30 and plus m/2 v2 cosine of 60. All of this together equals 45m, because that was my original momentum. So it's going to be equal to the final momentum. Now let's look at this again. This right here to begin with was equal to 0. It continues being 0. Then I can rewrite this as m/2 v1 sine of 30 equals m/2 v2 sine of 60. Why am I doing that? Because if they are subtracted from each other and that subtraction gives us a 0, there is no difference between them. Since there is no difference between them, they are equal to each other. m/2 and m/2 cancels, so disappears. Then remember that sine of 30 is half, and I'm just gonna replace the sine of 30 with v1/2. v1/2 equals v2 sine of 60. Sine of 60 is root of 3/2, so might as well replace that. Root of 3/2. And then what do you know? v1 equals root of 3 of v2. Look at that. They even drew it for us. See how v1 is longer than v2? That's because v1 is a root of 3 of v2. Root of 3 is 1.7-ish. Back to my pfx. So rewriting this, I have 45m equals, I'm going to factor out m/2, and inside here I have v1 cosine of 30 plus v2 cosine of 60. Remember that cosine of 60 is just like sine of 30. It's 1/2. So I'm going to say that just to save me the space. Cosine of 30 again is root of 3/2. So root of 3 v1/2. Boom. Now notice how I can cancel masses. We got is 45, and I have root of 3 over 4 v1 plus v2 over 4, and then instead of v1, this is supposed to be v1, I'm going to plug a root of 3 v2. 45 equals root of 3 times root of 3 is 3. So it's going to be 3/4 of v2 plus, that's not a v final, that's a v2, v2 over 4. So 45 equals 4/4 of v2. They're so clever. See how they drew the v2? Same as that it was 45. All right, we got it correct. And then all we need to do is figure out our v1, which will just be 45 roots of 3 meters per second, and that will be our v1.